It's just another 10 seconds. So. Okay, let's continue. With logarithms. Dun, dun, dun. You guys have your packet? Okay, you know that logarithms are related to exponents. So there are some similarities in what you know about exponents. They kind of transfer over to logarithms. You know that sorry, not log, that base b, what am I saying? B to the m times b to the n is equal to b to the m plus n. Right, like if you're doing x squared times x cubed, that's gonna be x to the fifth. Property of exponents. So it may not surprise you that when we talk about logarithms, there is a similar property that would say if you have log base b of a product, then this would be equal to log base b of m plus log base b of n. That's property number one, called the product rule. So go ahead and use that on these four and see if you could expand each logarithm. And make sure your neighbor got the same thing you did. We're good? Right, who'd like to tell us the first one? Well, let's see. Oh, it's so nice waiting for someone else. Karen, were you able to do anything with that first one? Okay, so you made it. I'm sorry, I can't hear. Log base. Log base 4 of. Oh, you added 7 plus 5? Oh, okay. We can't just, we're not saying to do m plus n. Although I could see how one would think that. This is going to be log base 4 of 7. It's actually simpler than you think. Then after this, it is plus log base 4 of 5. So we're not going to actually be able to add those numbers together. It's just a property of these logs. Yes? So do you need more time for B, C, and D to make sure those are all good? Let's see what you got. Ella, can you help us with B, please? How do you know that's equal to 1? Nice. Does anyone remember what that number is called? 10 is log with a like a blank 10. Sorry. This is a common log. But the number that goes here has a specific name. Did anyone remember what that's called? The argument of the log. So yeah, when the argument matches that base, it's just equal to 1. Thank you, Ella. Katie, can you help me with C, please? Are we okay with that, everybody? Like they're right on my paper, that'd be great. So log 11 plus log 3. Thank you. And Joanna. Cool. Thank you. I'm gonna. We remember that b to the n power over b to the n power is equal to b to the m minus n. So this property suggests the quotient rule of logarithms, which tells us, do you already know what this is going to say? Log base b of m. Let's write an m there. Is eluding me. Log base b of m minus log base b of n. So the second big property of logarithms is that the quotient rule. You already do a and b? Yes, ma'am. Oh, that's a good point. You can break up to 10 a little bit more, can't you? Yeah, you are correct. Yeah, there are different ways to express it, and it's not very clear, is it? Just says expand. They all mean the exact same thing. It's kind of like different ways of factoring it. It's just, it was nice to stop here because that's simplified nicely to 1. But you're right, you could break up that 10. If it's saying to expand it, I really like that idea, actually. Isn't that what it's saying? To expand each logarithm. It didn't say to simplify. Either one would be fine. Good point. Okay, A and B. Easy. Now that you can see how the products work. Make sure your neighbor got both of them. Here, I want to give you another shot at this. Any idea about this one? Thank you. Yeah, I kind of thrust you into that first one without any examples or anything. I feel kind of bad about that. So thank you. Perfect. Chloe, B. Could you walk us through what you did? Okay. And then you saw that the first one simplified to 3. Are we okay with that? Nice. And then log base E of 7. LM7. Yeah, please remember, I want your final answer. If it's base E, I do want to see the LM. I don't mind you switching to base E if if it makes more sense to you for now. Cool. One more. The power rule. We know that b to the m all to the nth power is equal to b to the m n. So this one, I think I'm going to motivate this a little bit differently though. I'm going to do some side work here. Log base b of m squared. And then we'll fill in the box. Well, m squared we know is the same thing as saying log base b of m times m. And now we could use the, what rule? The product rule. Our first one, we have m times m. So we would say log base b of m plus log base b of m is equal to 2 log base b of m And you can imagine what would have happened if instead of squaring it, we would have been cubing it. Then the result would have been 3 times log base b of m. And if it would have been to the 5th power, 5. So here, when you have log base b of m to the p, that simplifies. Is that a capital P or lowercase p? It does appear to be capital, doesn't it? I'll keep it capital. Log base p of m. Note, this does not say or does not apply to log base b of m to the p. Because that's a completely different thing, right? That's a whole log is being raised to some sort of power. If you see that something like that, you're going to have to find some different strategy. So keep that in mind. And by the way, for notation wise, if we have log base b of m squared, that would be written as, do you have any idea how this is written? Similar to sine. Remember when we have sine of x squared? Remember where that square went? I think this went after that sine, so it would look something like this. If you have a log that's being squared, that square would go in between the log and the argument. Okay. So for A, are these even? Oh, D is tricky. Be careful. And each using the rules of logarithms. So all three possibly. Okay. I'd like to hear from Elise. A. Thank you. Sam, did you get something for B? Is that how to say it? LN? That is correct. That's how to say it. And that 1/2, of course, came from the fact that square root of x is equal to x to the 1/2. So 1/2 ln of x. Thank you. Would like to tell us what they did for C. Yeah, Ellen. Are we good with that? Is there anything else we can do? Nice. Thank you for applying that to both of these. What do y'all think? If you're not sure about that, you can think about it as 5 times and then just use the property log of 4 plus log of x. But you can see that distributive property is necessary there. So you could just keep that in your head and say exactly what Ella just said. Nicely done. And also just when you have it like this, what you're not acknowledging is that both of them, oops, I forgot to write the 5. Both of them were originally raised to the 5th power. Oh, this is a landing spot. And when it says expanded, full expansion, there shouldn't be a distributive property involved until you finish the distributive property. Okay, make sure you can do D. I'll call on someone for D. All right, so we're able to do this. Okay. Great. Do we agree? Yes. Any questions? So we have expanded, but I think maybe some of you may have spotted something. Did you? You spot, yeah, Ella? Yeah, we could still simplify a little bit more. I don't want to be too late. Now, the instructions did say to just expand the expression using the properties. But it would be always be appropriate to simplify when possible in your expansion. We're good? Okay, so that's the big stuff for today. We have log base b of m plus n, mn, excuse me, is equal to log base b of m plus. So this is just a place to summarize everything. And of course, when it says base b, that just means any base. What is it, p? They can do this already. Let's work carefully. We'll be calling on two more people. Let's see what you got for a Charlotte. Can you help me with this one, please? Plus, you said plus base b of y. Do we agree? Are you able to go directly to the step? There's an intermediary step, of course. We just have the a instead of the m and the m and n. Log base b of x squared plus log base b of square root of y. But once you're adept at using all of them, there's no need to stop to even write that. Nicely done, Charlotte. Thank you. B is a little bit tricky. I'd like a volunteer for this. Yes, Jojo. What do y'all think? Oh, should it be plus? So maybe first it was something like this. Would that make sense as kind of a first step to do that? Because it is a product on the bottom, so you're right, there's addition there, but it's all being subtracted. That's all part of the m, or sorry, part of the n in this case. And then yes, when you distribute that, it will become this. Are you done with it? Okay. Are we good with this? No, these are all numbers. Well, except, well, I guess x and y, those aren't numbers. It's not really a polynomial, so there's no order. You may want, it does seem cleaner to do, but I don't care which order you put these in. Nicely done. Okay. Oh, look at this. We're going the other way. Using properties to condense into a single log. Evaluate if possible. Live with your neighbor as you go. Yep. Are we about ready? Okay, everyone, please show me what you got for A. Show me what you got. I'm looking for a, is it a 3? Because it's log base 4 of 64, so then the question becomes 4 to the what equals 64, so yes, it is third. For B, May, what'd you get? Are we good? Perfect, thank you. What's that? I think the only intermediate step here is that we have log of 4x minus 3 minus log of x cubed. And once we're there, we see the log of m minus log of n. Here the mechanical, putting one over the other. Huge error that students make is to try to use distributive property here. Why would that be inappropriate to use distributive property? Someone would say like log of this minus log of that. Yeah, like why is that inappropriate? Yeah, Ella. It's not multiplication. Distributive property is only for multiplication. So just because you see parentheses doesn't mean there's multiplication going on. That parentheses here, it just makes the entire argument obvious, right? If it would not have been there, that says something completely different. So thank you. Okay, for C, would like to tell us just the answer that they got. Yeah, Ellen, can you help us with this? I'm sorry, log the of x to the fourth over 36 root y like this. Okay, yeah, what do we think? Does this make sense? Is this right? No, because minus 6 and minus 6, not the 36 like the fourth. Not assume, but you could have a step in between because those negatives do complicate things, don't they? They do complicate things. So I love very nicely. Um, just to simplify things, what I recommend doing is saying log base b of x minus, and since they both have minuses, let's go ahead and kind of factor out that negative. And maybe this will be clearer to you. Would that help as a bridge to that end? So put all the minuses together, factor out that minus so you can see that product. Yeah. We don't know the one thing yet, but we know that we factor out a minus in both of these. We find a positive plus something. And it's common, like you have a bunch of pluses and a bunch of minuses, put all the minuses together. Uh, Factor out that negative one. So we have simply, let's put the x up. We have our product here, and then we have our exponent. The product results in the product at the bottom. I hope that makes sense. need a minute to discuss any questions you have about this, or to zone out if you like. It is now 32. We'll resume at 35. You can stretch. Now's a good time to do that too. We'll say 36. Solid 3 minutes. And part of it is completes the idea of exponents. Like everything needs an inverse. You can't have multiplication without division, or you can't have division without multiplication. But there are also applications in the real world, largely with seismic activity. I know that that is one. Oh, that's true. Yeah, I don't know, like the chemicals, but you are correct. Yeah, logs everywhere in chemistry. Okay. Oh, sure. You're like, oh, what can we do to do this? Exactly. And then you just have a log plus a log. You can have a log plus a log if you combine them. Yeah. Okay, go ahead and finish up your conversation. Okay. So, just a couple more words about this because I know these do get confusing really quickly. So just want to make sure everyone is clear about what's happening. I hope that you've already locked in the fact that this is equal to log base b of m plus log base b of n. Do you feel like you've already locked that in? Like that's not an issue? I hope so. The thing is, when you see something like what you see in the parentheses here, a lot of students want to use that immediately. You want to use that product rule. But what's getting in the way of using that product rule? Why can't we just go the reverse way of this and just make it a product? Well, those coefficients, right? That 2 is getting in the way, isn't it? This is getting in the way, isn't it? That 1/2 is getting in the way of us using that product here. So what do we do with those? We get them out of the way by making them exponents. And that's exactly where this 36 came from. That's where the square root of y. At first, you have to put those numbers up. This had to become a 2 right here. This had to become a 2 to the 1/2. And then we were able to use that product rule to bring them together. Okay, change of base property. I'm going to tell you this today, and then we're going to prove it in the coming days. But what this says is if for any reason you are dissatisfied with that base that you have been given, you may change it for one that you desire. That's all it says. Of course, you can't just erase a B and make it an A or something like that. But let's say you want base A, then you can say that this is going to be log base A of M over log base A of B. And that is just a formula. So I've chosen A, but we could also choose common log, which would look like log of M over log of B. I just happen to choose the specific one, base 10. Another special one we could use would be E. So we could use ln. So this would just be ln of M over ln of B. A lot of people get confused about which one goes on top and kind of doesn't hear it. If you can look at the orientation of the original M, it's above that on the bottom. And then the bases, just make sure it's whatever you want. If you want a base 4, you got it. You got base 4. Log base 4 of M over log base 4 of N. So how does this tell? Yes. That's a great question. Yeah, we did discuss with your neighbor. What is a log? Let's bring it back. Let's bring it back.
It's like one of those like I think that's I still do this when I learned how to count right now. Like yeah.
So it seems like conversation may have devolved a little bit. What is a log? What's the logarithm? A thing that we make you study? That's something. A torture device? Possibly. But no, seriously, what's a log? Anyone have any insight into this? And thank you for asking this question, by the way, because without this, there's no meaning. It has to mean something. So what is a log? Perhaps the story begins with, I'll put a reminder. The story begins with A to the B equals C, doesn't it? You know what that means, don't you? You start with a number, you raise it to a power, you're going to get an answer. So what is a log? It's just a rearrangement of this. So this is the same thing as saying log base A of C is equal to B. It's another way of looking at exponential expressions. That's why today when I was talking about the properties, I started with saying, remember, we know this about exponents. This is how it transfers to logarithms. So yes. I love it. These are great questions. So we know log base 2 of 8. We know that this is equal to 3. Yes, because we know 2 to the third power is equal to 8. So we could kind of understand logs enough to come up with an answer. But what if you have something like, for some reason, log base 4 of 27 came up? Well, I think you could get an approximation for this. It's going to be between 2 and 3, isn't it? Do we agree with that? It's between 2 and 3? Okay, what? Calculators in the back in the day used to only have 2 different log buttons, either common log or I think you guessed the other one, natural log. So because we weren't able to type that into a calculator, we say, hey, let me express this in a way such that I can type this into my calculator. Let's say I want to make this a common log. I could do that by making this log of 27 over log of 4, and suddenly I just type this in my calculator. You know what the answer is going to be if I type this in the calculator? Between 2 and 3. It just gives us a tool to calculate based on sort of limited technology. So great, thank you. Really great questions. Right, what's the point of all of this? And one point of math is it's such a beautiful creation of the human mind, but there are applications as well, of course, in science, mostly in science, technology. So yeah, I think we got this already. Change the common log. That's just this. That's this one, and this is natural log. Maybe we'll talk about the other one next time. I'm going to give you some time to work on your assignment. I think it's going to go pretty quickly.